Alrighty, hello everyone, happy Tuesday. Thank you again for joining me for this Facebook Live presentation where I will be talking about thermal infrared light and how awesome thermal infrared cameras are. So here we go. So first off, what exactly is or does infrared mean? And to explain that, I'm going to bring up the good old electromagnetic spectrum, which is drawn behind me, but so that it doesn't look mirrored, I'm going to go ahead and flip the camera. Oops, sorry. Okay. Flip. So, right here, oops, we have the electromagnetic spectrum. And what it is basically a range of frequency radiations and their respective wavelengths. So here you can see we have gamma rays, which are extremely high in energy. Then we have X-rays, ultraviolet, the visible spectrum, which is where we see and can see color in, which is about 390 to 700 nanometers. Then we have infrared, and then the radio waves, which is what our microwaves use, and you can see it's a much longer, bigger waves. So as you can see, the higher that the energy goes, the less the wavelength is. So you can tell by this peak-to-peak value right here, these are much shorter frequencies than the ones over on the other side. So where we're going to be focusing is the infrared, which is circled here, which is in the range of 75 to 1,000 micrometers. And what's interesting about this is that it can be broken up even more into what's called the shortwave infrared, the medium wave, and the long wave infrared, just depending on what it is you're interested in looking at. So now a little bit about thermal cameras, thermal infrared cameras. A lot of people think that the cameras measure surface temperatures, but what's actually happening is that it's measuring the intensity of infrared radiation that is emitted by those surfaces that it's looking at. So we all know that objects absorb and reflect or transmit heat at different levels. So that means that different materials will give off heat or cold energy at different rates, and it's that energy that's being detected by the thermal camera and then translated so that you can see the image on your screen, on the camera screen. And that translation has to do with the type of detector that's used on the camera. So typically for infrared cameras, it's common to use a microbolometer, what's called a microbolometer. And that's because for those type of detectors, they're actually looking for those differences in heat, whereas like a regular optical camera often uses like a CCD sensor, and that's just looking for collecting photons of light. So speaking to that, since it collects those photons of light, that means it sees in the visible spectrum for regular cameras. And that's where a lot of confusion happens with night vision and thermal infrared cameras, because for night vision cameras, it relies on ambient light, like say the moonlight, and it just enhances that to be able to see. But for, again, thermal cameras, you're looking at differences in heat. So I have some applications that I want to show. Oops. So thermal cameras were originally used or developed for military use during the Korean War, just to be able to spot enemies and tanks that they're deploying and things such as that. Another application, a huge application actually, is for firefighters, where they're in buildings trying to find and save people, but it's hard to see through all the smoke. The infrared cameras allow them to see the people because of their warm bodies. Oops. Their warm bodies, and they can find them and save them. And another big problem is forest fires, as you may know. So here you can see a lot of fog and smoke coming from the fire that you may not know is even there, but using a thermal camera you can see that there's actually a huge fire behind all of that. Some other uses are law enforcement. So for either surveillance or investigations when you're trying to find somebody, like say this guy, he was hiding in the bushes, thought he got away with it, but he didn't know they have a thermal camera, so they had no problem finding him, and wasn't his lucky day. Also, it's used for power line maintenance technicians, so they can locate where those overheated joints are, and you know, just be able to catch the issue before it is a potential hazard. So that's very important use as well. Another application is for building and constructing houses and inspecting them. So like during cold winters, you're gonna want well insulation in your house, but as you can see here, the roof is losing a lot of heat, so they're probably gonna wanna fix that. It looks like the windows are pretty well insulated, but yeah, so this is used to just inspect those spots that are not as insulated. And another application is physiological applications and what's called thermography, and that's just can be used for medical purposes, like seeing a fever, or just also monitoring animals. So here I think this is a cat. You can see where there's hotter parts of its body, and also here we have a cold-blooded reptile, and the only reason we can see him, he's cold-blooded, so he's this color purple, but the person's hands are really hot, so that's why you're able to make out the shape of the animal. And then same as these people, this hand is super cold. You can see like fingers look blue, and then here they're red because they're really hot hands. So now some limitations to thermal infrared cameras. Although they can see in complete darkness because it's just looking for those differences in heat, the quality can be affected by like rain and fog and atmospheric conditions like that, just because that's due to the light scattering like in those droplets or in the water, things like that. Another limitation is that it can't see through glass. So right now when I show you the thermal camera, you won't be able to see through my glasses, for example. And that's really interesting because for optical cameras, the lenses are usually made of glass, and if it can't see through glass, you may wonder what it uses for thermal cameras. And typically they use a germanium lens, which is just basically made out of a type of metal, so it's able to see through that. So that's all of that. Now I'm going to show you the thermal camera that we have here. So we have it set up on the tripod right here, and I'm going to stand in front of it, and then we have it displayed on the screen right here. So I'll place that there, and then I'll go ahead and stand in front. Oops. So as you can see, my my hands are extremely cold. They're really blue right here. Where my hair was on my shirt, you can see that it's really hot. My arms are really hot as well. Let's see if I put my hands together. Okay, my hands are really cold. I'll do this. You can see my hands starting to heat up right here on the palms. Or you can place it on your shirt for a couple of seconds, and then we can see my hand mark. Gosh, my hands are so cold right now. Well, usually you're able to see your whole hand print on the surface that you're putting it on. Sorry, mine are extremely cold right now. Yeah, you can kind of see it. And now you can see my glasses. You can't see through them because, as I said, the thermal infrared cannot see through glass, but as I take them off, you can see. Put them back on, and they look cold, or they're not transparent, can't see through them. I also have this garbage bag, and if it was, I couldn't find a black bag, but say it was black, you know, you usually can't see through it. Right now you can because it's white, but it can also see through this plastic, so I'll go ahead and flip the camera, and as I put it in front of the camera, you can completely see my arm, my hand. So since it's just looking for those changes in temperature, this basically becomes see-through. So that's really awesome. And another interesting thing about thermal infrared cameras is that they can reflect off of shiny surfaces. So I'm going to go ahead and flip this around to face the whiteboard. And you can see, not as clearly, but you can see me in the camera right now, right here. Here, I'm going to scoot it closer so it's a little more focused. So as you can see, right now it's facing the whiteboard, but you can see me moving back here, waving my arms a little bit. So I also want to show you one last thing. I'm going to flip this screen around, and then I have a blow dryer to show how that looks in the camera. So, whoops. So I'm going to go ahead and turn that on. Sorry, it's going to be loud. So you can see where it was heating up around right there. I know that they try and make these holders so that it doesn't get too hot around there and you can still touch it, but you can see that it's still collecting there a little bit through the camera. So that was all that I had today about thermal infrared cameras. If you have any questions, feel free to ask, or you can put in the comments. And yeah, thank you for joining. Have a good rest of your week. Bye-bye.